Number 6 of the 2025 AP Calc BC exam, the FRQ portion. This is the power series problem, Taylor series problem, okay? So they give us the Taylor series for a function f about x equal to 4. It's given by, this is the general formula. This is the first few terms, and here's the general formula again. And converges to f of x on its interval convergence. Using the ratio test, find the interval convergence for the Taylor series of f about x equal to 4. Justify your answer. So to find the interval convergence, we first need to find the radius of convergence. To find the radius of convergence, what do? The ratio test. So that's the setup right here. Yeah, there we go. Okay, limit as n goes to infinity, a sub n plus 1 divided by a sub n. That's the setup. Okay, I'll go through the algebra. X minus 4 to the, this is n plus 2, divided by x minus 4 to the n plus 1. You can subtract the powers. The n plus 2 minus parentheses n plus 1, that's just 1. Okay, so 1 power. Similarly, or 3 to the n and 3 to the n plus 1, subtract the powers. You get 3 to the minus 1, so 3 on the bottom. Okay, n plus 1 remains on top, n plus 2 remains on the bottom. Okay, x minus 4 does not depend on n. It's like a constant, pull it out in front, but we have to keep the absolute values because we don't know what x is. 3 is a constant, pull it out in front. Absolute value of 3 is just 3, so that's why you could drop it there. And now we have this left inside the limits, okay? As we take the limits, it's just 1. Remember, this is like horizontal asymptote, or remember the rational function, degree test, degrees are the same, take the ratio of the leading coefficient. So it's just 1, okay? So you get x minus 4 in absolute values, divided by 3. We set it less than 1 because per the ratio test, the limit has to be less than 1 for it to absolutely converge. Remember? So we start solving for this inequality. So x minus 4 absolute values is less than 3. Okay, moving on. So that means x minus 4 is between minus 3 and 3. Add 4 everywhere. 1 less than x less than 7. Okay, now we got to check our endpoints because remember the ratio test is inconclusive at the endpoints. Remember ratio test, if the limit is 1, it's inconclusive. This is 1 and 7 here are when the ratio test is exactly 1. So we got to check them manually. Okay, so at x is equal to 1, we plug in 1 into here, the general formula. All right, so we get 1 minus 4, which is minus 3. Okay, minus 3 to the n plus 1, we can rewrite as minus 3 to the n times minus 3 to the first power, right? Or you can even, actually, you can think of it like that if you want. You can even write it as minus 1 to the n plus 1 times 3 to the n plus 1, okay? So the minus 1 to n plus 1 is there. So I was saying this, also a 3 to the n plus 1. 3 to the n plus 1 divided by 3 to the n, that's just 3. Like before, we just subtract the power, so it's 3. The constant, I pulled it out in front of the summation, okay? So does this series over here converge or diverge? You have to show all these, I believe. So this is alternating series, so let's use the alternating series test. Maybe that will work, and it does. 1 over n plus 1 is decreased in sequence. I don't know if you have to show this, at least at the bare minimum, state it. Okay, I forget the scoring guidelines. So at the bare minimum, state it, please. And limit as n approaches infinity, 1 over n plus 1 is 0. So the series converges by the alternating series test. Now let's check the other endpoint. X is equal to 7. Plug in 7 into here as x. So we get 3 to the n plus 1 on top. Okay, simplify. That's just 3 over n plus 1. Hopefully you can already tell that this should diverge, but we have to show our work. So we can do a limit comparison test with the harmonic series. That's what I did. It's 3. Because it's finite and positive, I didn't say that here. Maybe I should have. But since this is finite and positive, since the harmonic series diverges, this guy also diverges by the limit comparison test. Okay, so we don't include 7, but we include 1 from the previous slide. So the interval convergence is 1 less than or equal to x less than 7. Okay, like this. You can also write an interval notation if you want to. Okay, they should accept that as well. Okay, that was all part A only. We have to continue. Part B. Find the first 3 non-zero terms and the general term of the Taylor series of f prime, derivative of f about x is equal to 4. There's multiple ways you can do this. Honestly, I think the easiest way is to just differentiate this guy. Remember, you can differentiate power series. Okay, so if you're comfortable doing that, I think that's the easiest way. Again, there's other ways to do it, but this is how I did. So I'm going to differentiate this guy, which we're differentiating with respect to x. So this n plus 1 and 3 to n are just constants, okay? Leave those alone. We differentiate this. We need the chain rule. So bring the power down first, power rule, n plus 1, x minus 4 to the n power, because n plus 1 minus 1, this is the power rule, okay? So, and then chain rule times derivative of x minus 4, which is just 1. So we're good there, okay? There's n plus 1's cancel. We can simplify this easy enough. So it's x minus 4 to the n over 3 to n. So the general term we have right there. Okay. And to get the first three terms, you could just plug in n equals 1, n equals 2, n equals 3. This is it, okay? I'm not sure how they want the final answer. Maybe they want it like this. Okay, so in our case, it'll be x minus 4 over 3 plus x minus 4 squared over 9 plus x minus 4 cubed over 27. Maybe you could just match this plus dot 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 plus and then general term, which we had right there, okay? Honestly, I feel like this is more clear. This notation I personally don't like. So I would write it like this, but if they want it like this, then do it like that. It's just a format thing in my opinion. So it shouldn't matter too much, but this makes it clear what the first three terms are and general term. Okay. But besides the point, if you're not here to nitpick on how to get every single point and just want to understand, hopefully I explained it. Okay. Part C, the Taylor series for f prime described in part B is a geometric series. For all x in the interval of convergence of the Taylor series of f prime, show that f prime is this guy, okay? So this is a geometric series, it says. So how do we find the sum of an infinite geometric series, assuming it's convergent? It's first term over 1 minus common ratio. That's how I remember it, okay? So what's the first term of the series? So by the way, I first rewrote it like this. So it's clear that's a geometric series, okay? Some ratio to the n power, okay? So first term is when n equals 1. So that's right there. Over 1 minus the common ratio, which happens to be the same thing, okay? So we just got to simplify to make it match that. This is a proof. So this is honestly the best type of question. The answer is right there. You just got to match it somehow, okay? Even if you don't fully understand anything, you got to match it somehow, okay? So I multiply 3 on the top and the bottom. So that's what I got here. And then I just simplified the bottom. So it's 7 minus x, okay? So it matches clearly. All right, and part D, it is known that the radius convergence of Taylor series of f about x is equal to 4 is the same as the radius convergence of the Taylor series of f prime about x is equal to 4. Does the Taylor series for f prime described in part B converge to the sum at x is equal to 8? Give a reason for your answer. So there's multiple ways you can approach this. I approached it from a very conceptual way, which I think is probably the quickest way to solve it. And that's actually for most calculus things. If you understand the concept, it's a piece of cake. The tedious algebra sometimes is what makes it hard for some people, okay? So let me explain the other way to do it first before I explain it my conceptual way that I did it, okay? X is equal to 8. So you could technically, go back to here. You can technically just plug in x is equal to 8. So that's 4, or even this one over here. That would be 4 over 3 to the n power, right? Remember the rule for a geometric series to converge? Absolute value r has to be less than 1. Our r is 4/3, which is greater than 1. So it does not converge. That's one way to solve it, which is not bad at all. You have to do some algebra, though. Okay, but the algebra is a piece of cake, to be honest, especially for when you're in this level of math now. But here's the conceptual way to understand it, okay? Radius of convergence is the same as they were saying. That's known. When you differentiate or integrate power series, the radius of convergence does not change. The interval of convergence can change, so specifically the endpoints. Okay? That is key. So at best, remember our interval of convergence for f was this. So the interval of convergence of f prime is something like this. It could be both less than, or it could be both less than or equal to, or this one could become a less than or equal to, this one can become less than, okay? Just the sign might have an equal sign or not an equal sign. That could change, but it's still 1 over here and still 7 over here, okay? We have to understand that. So at best, the widest interval of convergence for f prime would be this, both equal signs, or less than or equal to signs, okay? That's what I'm trying to explain here. 8 is for sure outside of the best possible interval convergence. So we already know that f prime does not converge to that guy at x is equal to 8. And I proved it earlier when I plugged in x is equal to 8, right? So we proved it. Okay. So the conceptual way that is you can figure out in 2 seconds in your head. The manual way to find it by plugging in x equals 8 was easy as well, but you have to show your work and took a few extra steps. But you can see how this is a good example, I should say, of how a lot of the times, calculus questions are a piece of cake if you understand the concept. Like this one, I knew right away. No, 8 is for sure outside the interval convergence. Let's say if it was asking about x is equal to 7, then this concept won't quite work. We actually have to go plug in. Okay, because it's at the endpoint. And remember, as I said earlier in this question, also that at the endpoint, the ratio test is inconclusive. That's the whole point of in part A, we had to check the endpoints. Okay, the endpoint behavior could change, but since 8 is for sure outside even the endpoint, the endpoints, yeah, will for sure diverge. Okay, hopefully this was helpful if you're studying for an exam. Okay, whether you're studying for AP Calc, so you're probably watching this years in the future or a year in the future, something like that, because I'm filming it right after the exam, not too long after the exam, or if you're studying for another school's class, hopefully this is helpful as well, okay? And hopefully I'll see you in another video as well in the future. Bye.